It shows, I can tell that it's recording on my end. I can see the little record. I'm assuming that's what it is. Okay, you guys, inverse functions. Remember inverse functions? Remember? No. Okay, way back when. Some of you, very, very long ago. Remember my function machine pictures?
No.
Yes.
No.
Well, I do not remember any of this.
That's like a.
Are you
What
sure
is
we
this?
did
What is
function
this?
machines?
My function machines.
I don't always know.
We've definitely done this.
Function
We've seen
machines.
these machines.
Okay, so if two functions are inverses of each other, the idea is if we were to input, let's input A. A represents a number. Let's input A into the function f, and let's say our output is B. If we then take B and input it into the function, which is a function, but has the relationship with the function f that it's its inverse, so we use this notation to indicate that it's f inverse, then the output will be
Hey.
A. Yeah?
Yeah.
So for a function to be an inverse and to have an inverse, it has to be a special type of function. What type of function does it need to be?
Conservative.
Doesn't necessarily have to be
Conservative?
I've never used the word conservative before.
Conservative.
Conservative, I guess it's like one adjective you could apply to it, I don't know. It's a conservative function. Interesting. Okay. Well, let's think about this.
Are we recording? Sorry.
We are recording, although Joey can't see this right now. Sorry, Joey. Let's think this. If I took a different number, C, and I input C into F, and let's say it also had an output of B.
What do we do?
Still a function though, because every input corresponds to exactly one output, right?
Oh, one-to-one function. Oh.
If I were to take B for this
That a liberal
function
function?
and input it into its inverse, what would it output? A or C?
Both.
Well, then it's not a function,
Sorry.
right? So for a function to have an inverse and to be an inverse, it has to be a one-to-one function. Every input must correspond to exactly one output, that makes it a function, but every output must correspond to exactly one input. So their graphs must pass the vertical line test, but also the horizontal line test, right? Every x maps to exactly one y, every y maps to exactly one x. You remember this, yeah?
Yeah.
Yeah, totally. Okay. So another way to represent this is let's say the function f has the point a comma b. Its inverse, which I can name it g. I can name it. It's a function, right? We use this notation, the -1, to indicate that it's the inverse. Not the same as 1 over f. It's just the notation that indicates that it's the inverse. And b comma a would be a point on f inverse, okay? So when two functions are inverses of each other, they have the opposite domain and ranges, right? Like you take the domain of f, and it will correspond to the range of f inverse. If you take the range of f, it would correspond to the domain of f inverse. Yes?
Yep.
We also had as part of the definition of inverse functions, and we used it back in pre-calculus to verify that two functions were inverses of each other. But it's part of the definition. Remember this? So if you think about evaluating f at the entire range of f inverse, okay, or composing f with f inverse, that should simplify to be x. Like if you had the two rules for f and f inverse and you were to compose the two functions, they should simplify down to x. And conceptually, you can think of that as, okay, if you're evaluating f for the entire entire range of F inverse, the output should be the domain of F inverse. So this is true for the domain of F inverse. And then the opposite also has to be true, or the reverse. So F inverse composed with F must simplify to X for the domain of F. In pre-calc, we use this to help us with verifying that two functions were inverses of each other. But now, we're going to use this to help us with determining the derivative of an inverse function. Questions so far? Are we okay? Do we remember what an inverse function is? It has to be one-to-one to have an inverse. Domain and range switch. Right, so if A comma B lies on F, B comma A lies on its inverse. Are we okay? Okay. So now we're going to look at inverse functions from a calculus perspective. Now that we have like all of this knowledge about calculus, we're going to be looking at inverse functions using our calculus brains. Okay. So let's look at some of these statements about continuity and differentiability of inverse functions. So if f is a function whose domain is on some interval I, and if f has an inverse function, the following statements are true. And if f has an inverse, it means it is what type of function?
One-to-one.
One-to-one. Okay. If f is continuous on its domain, then f inverse is continuous on its domain. So if a one-to-one function, a graph that would pass the horizontal line test and the vertical line test, is continuous on its domain, meaning over its domain, every input corresponds to an output, a value in the range, then f inverse would also be continuous on its domain. Now, a function can be one-to-one and not be continuous, right? It could pass the horizontal line test if it not be continuous. Like 1 over x, right, is not continuous at 0. I guess it's continuous over its domain. But f inverse is also continuous on its domain. Okay, if f is increasing on its domain, so if f is a monotonic function, you've heard me say that before, yes? When we were talking about increasing, decreasing, I know I mentioned the term monotonic. So it means that a function is either increasing over its entire domain or decreasing over its entire domain. So if f is increasing on its domain, then f inverse is increasing on its domain. So think about that for a second. Does that make sense?
On its domain or its range?
In its domain. So think about that. For a function to be increasing, going back to, remember our pre-calc definition of increasing? Like as x is getting larger, the y values are also getting larger.
Yep.
So then if you take those values from the range, right, where those values were getting larger, and then you use those values as your domain, they will map back to the x values that would also be getting larger.
That makes sense.
Yeah.
Does it have to be a monotonic function?
Yes. Yes. So if f is increasing on its domain,
So like its entire domain.
its entire domain, yes, then f inverse is also increasing on its entire domain. To be one-to-one, a function has to be monotonic.
Why does it have to be? Oh, yes. Yeah. Horizontal.
Or
Does it?
X cubed be monotonic?
it is. But going back, I realize because you're thinking about it, x equals to 0, how it levels out for a second. But if we fall back on our pre-calc definition of increasing, as x is getting larger, or the y value is getting larger. So if you think about a point directly to the left of 0, 0, wouldn't the y value there be less than the y value at 0, 0, or at 0? A function can be one-to-one and not monotonic, but it would only be like a piecewise function where that could happen. Let me double check something real quick. I don't want to give you guys
You consult the
incorrect
college
statements.
textbook.
What?
You consult like you want.
I'm consulting your textbook, which I know you guys all read all the time.
Yeah.
Math textbook, we just flip it open
Yeah,
on
just wait for
Yeah,
Emma.
just the same weekend, just on the weekend, we just little.
a light reading.
Exactly.
You guys don't just read like over your break. You don't just like read this.
No, that's
No.
all I did.
Unfortunately, I speak the truth,
Stefan, you're lying.
and I did not read
If
the
f
textbook.
is strictly monotonic over its entire domain, then it is one-to-one, and therefore has an inverse function. So a function can be one-to-one and not necessarily monotonic, but if it is monotonic, then it will be one-to-one. Does that make sense?
It's like a-
Like the one that I was
Squares
thinking
with
about
a-
is like, and I know it's a piecewise, so it's kind of tricky, but like something like this, which would pass the horizontal line test. It's a piecewise, would pass the horizontal line test, not monotonic though. But if a function is monotonic, I say tonic, monotonic, then it will be one-to-one and will have an inverse. Okay, so just to clarify that. And then if f is decreasing on its domain, f inverse will also be decreasing on its domain. Now let's think about this next one. And let's think about x cubed. If f is differentiable on the interval containing c, and f prime of c is not equal to 0, then f inverse will be differentiable at f of c.
Yep.
Let's think about when this wouldn't be true. So let's think about, like with x cubed, which Bridget just mentioned. You remember what x cubed looks like? The chair.
You do.
The chair. Now at x equals to 0, f prime of 0 would be 0, because there's a horizontal tangent line there, right? X cubed, y equals to x cubed, 1-to-1, has an inverse. Do we remember what its inverse is?
It's the opposite chair.
It's like sideways.
The sideways chair. Yeah, the sideways chair. Do we
That's what I meant.
remember what the
Yeah.
equation of that would be?
Cube root.
Yeah, cube root functions. So
Yeah.
looking like this. So y
The Brabant's
equals
really
x
easy.
to the 1/3 or cube root. And then also, do you guys remember, like if you knew a function was 1-to-1, so it has an inverse, and I presented you with the equation, what's the process that we use to find the equation of its inverse?
Swap the x and the y.
Yeah, you swap the x and the y, you solve for y, right? So like for y equals to x cubed, if we did that, we'd have x equals y cubed, and then solving, so this equation does represent the inverse. But then if we want to have the equation that we know represents a function, right, y in the y equals form, that would be y equals to the cube root, or x to the 1/3 power. Okay. What's f prime of 0 for y equals x the 1/3 power though? It's undefined because what type of tangent line occurs there?
Vertical tangent.
Vertical tangent line, right? So what this says is if f is differentiable on an interval containing c, as long as f prime of c exists and is not equal to 0, then f inverse will be differentiable at f of c. Okay. It's when f prime of c is equal to 0, so if there's a horizontal tangent line, that f inverse would then not be differentiable at f of c. Do we follow this? Inverse functions, I feel like always take an extra second to think about. Are we okay so far? Questions? Think about inverse functions and not.
Is it the case that it will be that every horizontal tangent line will turn into a vertical tangent line across any function that has them?
Across like two functions that are inverses?
That if the original has a horizontal tangent line, the inverse will have a vertical tangent line at the same point.
Hold the thought.
Okay.
Hold the thought. Okay. Because rather than me just telling you, just hold the thought. So this next theorem, you guys, is going to be important. Like, you need to know this, mainly this, because questions about the derivative of an inverse function are going to come up, probably in the multiple choice section. So what this says is assuming that f is differentiable in 1-to-1 on the interval I, so you know f has an inverse because you're given it's 1-to-1. If f has an inverse function, which we'll call g of x, we're not going to use f inverse because we're also talking about derivatives and like derivative of f inverse, a lot of notation going on, right? So you're usually given like the function g is the inverse of f. Okay, then g is differentiable at any x for which f prime of g of x is not equal to 0. This goes back to what this statement said. G prime of x, so the derivative of, so you're presented with a function, and if you needed to determine the derivative of its inverse, g prime is 1 over f prime evaluated at g of x. Super easy to derive, okay? So let's go through. You can memorize that, or you can derive it. So remember how I talked about this was part of our definition of inverse functions, right? When you compose them, they simplify to be equal to x.
Yep.
So f composed with g of x, if f and g are inverses, should be equal to x,
Yes.
right? This would be true for the domain of g, right? If we think about taking the derivative of this with respect to x, well, the right-hand side, derivative of x with respect to x would just be 1. And then on the left-hand side, to find the derivative of f composed with g, we would need to use chain rule. So derivative of the outside, leave the inside alone, times the derivative of the inside. Do we see where we're going with this? Did you say no?
Yeah. Yep.
So g prime is equal to 1 divided by f prime evaluated at g of x. Or f prime composed of g of x.
Very peculiar.
Interesting, right? Now watch this. So based on this, if f and g are inverses, so that would mean that if the point a comma b was on the function f, then you know that b comma a would lie on the graph of g. Yes? Oh, let me erase my... Okay, so let's say that we were finding f prime of a, and that's equal to a value, c. Okay, so leave that for a second. Then let's say we wanted to find the slope of the tangent line at b for the function g. So we wanted to find g prime of b. So using that formula that we just came up with, g prime of b would be 1 over f prime of g of b. You okay over there? No. No. What is g of b? A.
Oh crap. True.
And what's f prime of a?
C.
Whoa, what you looking at?
Oh. Oh crap. Intriguing.
So let's say that f prime of a is equal to 0, horizontal tangent line. Then g prime of b would be undefined and would correspond to a vertical
so that's
tangent
why
line.
They say if f prime g of x is not equal to 0.
Okay, so, and the slopes of their tangent lines, so the slopes of their tangent lines would be reciprocals to each other, as long as c is not equal to 0. Okay. Let me, here, I'm gonna like box this. Maybe that wasn't a good idea. Maybe we just need to like resize this. Full box. We're going full box. There we go. Looks a little better. All right, so let's look at some of the problems that might come up in your textbook. We have some throwbacks coming your way, you guys. You just wait. Throwbacks. Okay, so let f of x be equal to this cubic function. G is equal to f inverse. If f of negative 2 is equal to negative 14, find g prime of negative 14. So the first thing that I would do here is I would set up, okay, g prime of negative 14 would be 1 over f prime of g of negative 14. Okay, well, we know f of negative 2 is equal to negative 14, so how could we find g of negative 14? Like find the equation of G?
Yeah.
I guess that could be one option, but if you know that they're both inverses, if we were to input negative 14 into G, what would the output be?
Oh,
Negative
2.
Negative 2, right? Because negative 2 comma negative 14 lies on F, so that means negative 14 comma negative 2 would lie on G. So we would have 1 over F prime of negative 2. Well, we do have the equation for F, so couldn't we find F prime?
We could. We definitely could.
So F prime would be 3/2 x squared plus 3. So if we're finding F prime of negative 2,
4, 2.
that would be 3/2 times negative 2 squared plus 3. So is that 6 plus 3 is 9?
I think.
Which makes sense, right? Like with what we just said above, like if F prime of negative 2 is equal to 9, then G prime of negative 14 should be the reciprocal. That's more like a textbook problem, I feel like. This is more like what I feel like you would see coming up from the College Board, from good old CB,
Yeah. See.
as like probably a multiple choice, okay, presented with a table. So F and G are inverse functions. We got to find G prime of 3. Well, G prime of 3 would be 1 over F prime of G of 3. So once you know that, it's basically just plug in the values, right? So reading the table, G of 3 would be 4. And then F prime of 4 would be 1/2, which means G prime of 3 is equal to 2. Why don't you guys, in the groups that you're sitting in, why don't you guys go ahead and try the next one? Find G prime of 7. So with your groups that you're sitting in, go ahead and try and find G prime of 7. G prime of 7.
What is G of 7?
Is that the question you should be answering?
That is the question I should be asking. I'm asking it. Do you guys know what G of 7 is?
That's a great question.
Well, we have to find the inverse of
I have to find the
X.
inverse of the
If
function.
you go to that equation, you can find which
You
x
get the inverse?
is
We'll
x.
use the
What?
inverse.
Get it? Get it?
Guys, right, so
What is that? What did you just draw?
I was trying to draw, but anyways, right, if you plug in 7 here, you get 1.
Well, you're not going to get a letter.
So therefore, the output of this equals 7.
What is
Whoa.
that? What do you mean by
Whoa.
this? What do you mean by that?
That's
Oh,
the
valid.
So you just solve
I
for
see
x.
this. Why are we solving for X?
Why does that
That's
output
what the
that?
inverse equals.
Where? Why are we so
Rudy was I know what I'm talking about.
So
What?
I had this.
It's inverse. Okay, I got this. I got this explanation.
7 is
Alright?
equal to A, right?
Well, I think he got
Hey,
this.
I got this. Let me cook.
Yeah.
Inverse, right? Inverse. So which means equals to, let's say this equals to, let's just say this equals to A, right?
Okay.
Then this is A, this is B, which means because these are the inverse. This A, if you plug in the B right here, this is gonna be A.
Okay.
So
Oh, so that's
So you plug in G of 7.
you plug in 7.
7.
You plug in 7.
for f of x.
7.
Yeah, because of the input output,
of
because the
X
inverse,
will
you look at the
equal
machine, the
7.
boxes,
So
and they just
7.
X where would equal 7?
Wait, 7 equals.
So I heard Zafon say you would plug in 7 for f of x.
That is right.
Yeah.
So x would not equal 7, right?
F of x equals.
Yeah.
Okay.
That's
And then you solve for
That's
X.
what you meant.
What'd you get for J?
Wait, explain it one more time, Sean. Just something.
So then 2 negative 2 equals x. Wait, okay. I don't.
Rohan, I like
Good.
to write it out like this sometimes, or in the form of like the fact that f of a would be equal to b, so that means g of b would be equal to
So negative 1
a.
equals x cubed, right? But it's still negative 1 because cube root of negative
That's
1 is
right,
negative
that's
1.
right.
So
I'm bad
just
at taking
He's just taking the b,
Take a look.
plugging it in.
6.
Yes.
Equals.
Wait, no. Yes. Uh-huh. Yeah, that's what I got.
1.
I dropped a negative sign, but I found it.
Don't do that.
Alright, so now when we go here, so f of negative 1 is what you're ridiculing.
Yeah, I would have to say that.
1 over f prime of negative 1. So what is f prime?
F prime. Well, we have to derive it. What?
Okay.
And after arriving f of x, I got the answer negative 6x squared.
Oh, no, that's, no. 3 times
So
2
back,
is
that's
6.
so back.
Yep. Yep. Yep.
Squared? Okay, so negative 1 times negative 1 is 1, 1 times negative 6 is 6. Negative 6. So I got negative 1, 6.
I would have to.
Do we have an answer, you guys?
That was on the next page.
What?
Did we get? I think I heard it. Did we all get negative 1, 6?
I did.
Okay.
Let me jot that down. So F question mark was 7. G 7 was question.
Any questions on that one? Okay, you guys, we're going to get a little triggy with it now.
Oh man.
So we need to find g prime of 1/2. So if we're thinking about finding g prime of 1/2, right, that would be 1 over f prime of g of 1/2. Well, if f is equal to sine, wouldn't the inverse be arc sine?
Hold on. Repeat what you just said.
Arc sine.
If f is sine, wouldn't its inverse be arc sine or inverse sine?
That is true. That is very true.
And if you remember what we had restricted the domains of the trig functions to make them 1-to-1,
Oh crap.
we had restricted the domain of sine to be negative pi over 2 to pi over 2 to make it a 1-to-1 function. And pass
So it's
the
like
horizontal
this, and it's
line
like that.
test. Okay?
What that mean?
Which means that the range of its inverse of arc sine would be between negative pi over 2 and pi over 2, right? Yeah. Okay, well, we need to figure out what g of 1/2 is. And kind of the same thought process. You don't even need to write down arc sine if you don't want to. But we're thinking, okay, f of what would be equal to 1/2 because we're trying to find g of 1/2. Now you could just think, well, what is arcsine of 1/2? But when you're thinking about, well, what is arcsine of 1/2, you're probably thinking about where sine is equal to 1/2, right?
I'm saying.
And you're thinking about from negative pi over 2 to negative pi over 2 to pi over 2, where is sine equal to 1/2? Well, negative pi over 2, isn't that quadrant 4? Like thinking unit circle, that's negative angles that terminate in quadrant 4. And then from 0 to pi over 2, that's Q1. So really you're thinking about what angle in quadrant 1 would make sine equal to 1/2.
Pi
Pi over 6.
over 6. Your unit circles.
Which you also could have thought like arc sine of pi over 6. Hey, or no, sorry, arc sine of 1/2. That is pi over 6. Okay, so g of 1/2 is pi over 6. So then you need to figure out what f prime of pi over 6 would be. Are we okay over here? What is f prime? Did I hear it?
Cosine of x, yeah.
I should have made you repeat it instead of just answering. Did I hear it? Yeah. Yes. So f prime of pi over 6, that's cosine of pi over 6. What's cosine of pi over 6? Good. Okay, he came back with a quick answer on that one. So 1 over root 3 over 2, that would just be the reciprocal, which would be 2 over root 3, or 2 root 3 over 3. That was fun, right? A little bit of a throwback. But don't worry, we're about to go even further throwback
Let's go even further
to
beyond.
chapter 2 of pre-calculus.
Chapter 2.
So just wait. Before I move on, does anyone have questions on this? Do I need to explain any part of this? Bridget?
This is definitely a stupid question.
No.
There are no stupid questions, Bridget.
What's the difference between arcsine and cosecant?
Oh, cosecant's the reciprocal of sine, right? So cosecant is equal to 1 over sine. Okay. Arcsine is the inverse of sine. So we're thinking about inputs as being ratios and outputs as being angles. If you think about for sine, the inputs being angles and the outputs being ratios.
Okay.
So taking the range of sine, which is values between -1 and 1, and inputting into inverse sine or arc sine, and then the output will be angles, which would be between -pi over 2 and pi over 2, because that's how we restricted the domain of sine. Here, here, we were just doing this in pre-calc, so I can easily pull it up.
D-Roof.
Do you remember this?
I'd rather not.
You'd
This was not fun.
But when we restricted the domain of each of the trig functions to make them 1-to-1, so then we could just think about flip-flopping. Because we restricted it so that all the values that are in the range were passed through. But the function would also pass the horizontal line test.
I do remember.
Remember that? Like, you know it happened. Or maybe not like remembering like the actual details of the conversation, but we know it happened. Right? Yeah. Totes.
I
Okay.
would believe so.
All right, this one. Let's find G prime of 8. Did that answer your question, Bridget?
Yes.
Okay.
I'll work on it.
Okay. G prime of 8. So let's set this up. G prime of 8 would be 1 over F prime of G of 8. Okay. So that means we need to figure out what value would make F equal to 8, right? To figure out what G prime of 8 would be. So we go, okay, let's set F equal to 8. And then get 0 on one side. And then we're like, how do we factor that cubic? Unless you know Cardano's formula.
What?
It's kind of like the quadratic formula for cubics. Cardano.
Well, it's
Cardano.
simple. It's just the cube root of negative q over 2 plus the square root of q squared over 4 plus p cubed over 27.
Yeah.
Plus the cube root of negative q over 2 minus the square root of
Simple
q squared
formula.
over 4.
Don't have a song for that one though. Maybe that's why we don't teach it.
We never learned that.
No.
Okay, good.
Because
there's
what
one.
else? There's a song?
Hold on.
This would have helped me get through, like.
That's so
Something
classic.
else, wait.
This is so biblical.
Send that one to me.
Why is this so biblical?
Oh, I found it here.
It's 4 minutes long.
Yeah, we're not gonna go the whole thing.
Why is it?
It's good, it's good.
Man,
Respectfully, this is horrible. Wait.
Yeah, no. I don't think I was introduced to Cardano's formula until my abstract algebra class, like modern algebra class. Like you're dealing more like in the complex numbers. But anyways, you guys do know how to factor this puppy.
Can we do a little complete in this?
what?
No, it's not a quadratic.
What?
Yes, but what do we have to do first? Like, how do we know? Yeah, who are the candidates? Do you remember that? The possible rational zeros, rational roots. Yeah, so we're like, okay, what are the possible? Yeah,
What are you talking about?
trip down memory lane. Possible rational
I don't.
zeros. Here you go.
You're younger, Michael,
Okay,
so you're-
plus or minus, the factors of 7 are 1 and 7. The factors of 2 are 1 and 2. Right? All the factors of the constant over all the factors of the leading coefficient. So then we go, okay, all the possible rational zeros are plus or minus 1, plus or minus 1/2. Plus or minus, this one isn't too bad, 7, plus or minus 7/2.
We have to like do this on the test.
Maybe.
It's just like, okay.
You know what I'm saying?
What did I say to always start with? What was my suggestion to always start with?
The one.
1 or negative 1, yeah. So I'm going to use 1, and you can use synthetic division. Okay, so using synthetic division to
just using everything.
everything. Throwback.
This is just not necessary.
Okay, but it is. Okay, bring the 2 down. 2 times 1 is 2. Bring the 2. 2 times 1 is 2. 7. Oh my goodness, look! It works.
Oh, so it's 2x squared plus.
So what we know from here, I'm running out of room, I'm gonna add a page. Okay, so what we know from here,
What do you mean you gotta do it again?
no, you don't, is that we have x minus 1 times 2x squared plus 2x plus 7. Now here's the thing, this is not factorable over the real numbers, right? And we're only in the real numbers in here.
Wait, so
Over real
so how do we
numbers.
get these pop? But where is it? What is it possible? Like
Rational zero.
Oh, it's the last one.
You're taking, like, think about like when you're factoring using guess and check. Aren't you thinking about like the factors of the constant and the leading coefficient? Right? In order to get 2x cubed, and in order to get 7, the minus 7, you have to think about the factors of 2 and 7.
yeah. So you just put the top one like or
The factors of the constant over the
Oh, okay.
factors of the leading coefficient. And then all of those different combinations. So 1 over 1, 1 over 2, 7 over 1, 7 over 2. This was chapter 2.
32.
Chapter 2
So
of
if-
pre-calculus.
If the factor, if like one didn't work here, you just do it again,
Then you go to -1.
and you know it worked. Like it wouldn't work if the last.
If none of them worked, then there's no rational zeros.
So let's say
Right,
it's
but
like 6.
you know it works because the last term is 0, right? Like in this.
Yeah, the remainder is 0. So it divides evenly in. So x minus 1 times 2x squared plus 2x plus 7 is 2x cubed plus 5x minus 7. Now, you could look at that and be like, I can't figure out how to factor it. But you could also think, quadratic formula, x equals negative b plus or minus the square root
necessary.
of b squared minus 4ac all over 2a. Okay, where this would be negative, so there's no, like that does not factor, they're not real zeros. They're imaginary, complex zeros. They would have I. So it doesn't factor anymore. So that means that x is equal to 1.
Wow.
Okay. Yeah, what was the question? What are we doing? So g of 8 is equal to 1. So 1 over f prime of 1, and then now it's just finding what f prime is.
So that x we just found.
we halfway done.
Like what is that for again?
That was in order to find what f evaluated at what is equal to 8, because g of 8 is equal to that value. So g of 8 is equal to 1. Right? This tells us g of 8 is equal to 1. And then f prime of 1 will be 11. So 1 over 11. Easy peasy, lemon squeezy. Right? Do we have any more throwbacks? That was my biggest throwback of the day, you guys.
Here's some notifications.
Squeeze me.
What?
I have a question. How did you get from no knowing what the zero was to the equation.
Because that factored, so since the remainder was 0, that tells me that x minus 1 times this, 2x squared plus 2x plus 7 is equal to 2x cubed plus 5x minus 7. This does not factor any further, because if you're looking at it and you're trying to get some check, it doesn't work. But if you double check by if you pop it into quadratic formula, underneath the radical is negative.
Yeah, so for the sympathetic division, you were testing 1.
I was testing whether 1 is a 0.
And so you take the opposite of whatever you get for the 0.
X minus 1, yeah, because if I apply, remember, a 0 is a value of x that would make the output 0. So if we were to plug in 1 here, that would make this factor 0 and then make the right-hand side equal to 0. Now, this next one. If f of x is equal to 3x squared minus x, we okay over there?
They're disturbing the peace.
They're disturbing the peace. Isn't that like a rap song? No? No? That's not what you were referencing.
No.
Gotcha.
Just like generally like disturbing others.
Okay. I'm just gonna like stand over here for a little bit.
Yeah.
Just haven't gotten, although I
Maybe you don't want to sit over here.
yeah. Okay. All right, you guys, so F.
No rough algebra.
You were quite the storyteller today.
Every day.
Every day.
Nowadays, messed up.
Okay. So f of x equals to 3x squared minus x. And g is its inverse. What does the graph of f look like, though?
Wait a second.
One of these.
Wait a, in the words of my son, wait a second, doodle.
One could say that's not a 1-to-1.
One could say that. One could say that, right? Because it's a parabola, right? However, if we were to restrict the domain, couldn't we make the function 1-to-1? Like, what if we were to, well, not, I wouldn't say, why would you say 0?
It's right in the middle, so then you have all.
Well, how do you know 0's in the middle?
I
It's
don't.
not 0. It's the
I just
vertex.
took a guess.
The vertex cuts that graph in half, right? Like, so if we restricted the domain to be x less than or equal to whatever the x value of the vertex is, the x coordinate of the vertex, or x greater than or equal to the x coordinate of the vertex, then we would have two intervals where f would be 1-to-1 and then therefore have inverses. You have so many ways of finding the vertex, you guys.
It's like
But with our calculus method, what about, let's use calculus though. So using our,
Derive it and then find the tangent line. Yeah, the flat tangent line.
the flat, what do we call that?
The
Flat line.
horizontal.
The horizontal tangent line. So let's find f prime. Let's find f prime. Ooh.
But you know, the class we're in is called AP Calculus, AP. So how about we do some calculus?
Let's do some calculus. Okay. Set f prime equal to 0 because you're looking for where the horizontal tangent line occurs. So at x equals to 1/6. So what that means is that you could have f equals 3x squared minus x on the interval for x less than or equal to 1/6, and that would be 1 to 1. Or you could have f of x equals to 3x squared minus x for x greater than or equal to 1/6. Okay, either of those equations would be 1 to 1.
So you have to declare this. Otherwise.
You have to declare this, and here's why. We're actually going to end up with more than one answer here for g prime of 10. And that's because wouldn't there be 2 places where f has an output of 10? So like we'll have a slope on the left side over here, and then we'll have a slope on the right-hand side for g prime of 10. So we'll have a value for g prime on the left interval, and then a g prime of 10 on the right interval. They'll just be opposite signs. So g prime of 10 would be 1 over f prime of g of 10. So that means we need to find what g of 10 would be on each side. So for f defined on x less than or equal to 1/6, we set f equal to 10. And that factors. So is that 3x, x? That would have to be minus 2, 3x plus 5, x minus 2. So x equals negative 5/3 or x equals to 2. So x equals to 2 wouldn't be on this interval. This would be for that first interval. But then for x, so for f defined on x greater than or equal to 1/6, then you would end up with x is equal to 2. So for x less than or equal to 1/6, g prime of 10 would be 1 over f prime of negative 5/3. So we need f prime. Oh, we already found f prime, huh? So f prime would be f prime of negative 5/3. What does that end up being? Negative 11. So negative 1 over 11. And whenever x is greater than or equal to 1/6, g prime of 10 will be 1 over f prime of 2, which ends up being 1 over 11, because f prime of 2 is 11. So 2 answers.
Do you have to do both in the test?
Yeah, of course.
If I ask this exact question, yeah, you should have both answers there.
Maybe you should ask me this exact question. Just an idea. I would go with that.
I should always just ask you questions I've already shown you
No, not always, just like being
and get assigned you.
I'm a big fan of
Gotcha.
those.
Cool.
I'm a big fan of that.
All right, you guys, why don't you try the last one in your groups?
Oh, yeah.
You can do it.
0 to the power of 2, eh? Isn't it just like this?
Is this going to be like the last one we just did? Or?
No, there's only one answer to this one.
That's when the.
Is that the thing that told us like how to go manually?
Yeah.
Yeah.
So 0 to pi over 2. So that's only Q1, right?
Yeah. G prime. The question is, what is G prime?
You don't technically have to think about like using arc cosine here.
I got and answers.
Hold on.
1 over that.
What did you get? Yeah.
I could have done
Me too.
that. We got like the same thing. Did you get mine, Jared?
So what is your
So maybe they'll-
Yeah.
Right.
Ooh.
Jared, maybe you should wear a mask too.
Don't worry, I got one for you.
Oh, you do?
I do have one for you.
I would not. I would not accept that. Is that used?
No.
Oh, okay, then I would.
It's not used.
I folded it up too. I folded it up too.
So
It's not used.
You know, I would take that, Jared. Just not even.
Hey, what did you, bro?
Bro, I have just, you can do
Once I
arc
set, I set F
What did you guys get?
No, when you know.
Bro, it's.
The domain's given. That's Q1, that's
Bro,
only.
what?
I got this.
No, bro.
What did you do?
That is, what did you do here? Dude, just spin. What? No. What did you do there? So that's what this door said. I don't.
But you don't have it.
Sean, how did you do all that?
Why'd you do all that? Why'd you do all that?
It was only.
Do we have an answer, you guys?
Sean did like 20 extra steps. He did like, and like the weird thingy.
Yeah.
He did this.
Oh, well, why not? He came up with the general solution set. Yeah, he came up with the general solution
That's
set.
not needed. It's unnecessary. A waste of time.
I wrote out an extra possible answer and then crossed it out. What did we get, you guys? Or are we still working? Do we need another minute? We need another minute.
Okay, my units are.
That's what I thought as well.
Okay. You're telling me sine of pi over 6
I
isn't,
think we call it.
well, it's pi over 6 times 2, right?
Which is sine of pi over 3.
Sine of, hold on.
I don't really know.
Negative sine 2x times 2.
No.
No, I'm casting.
You won't get, you only get $3, chill, don't.
So then plug
You
in
only
times
get $3 back.
2x.
Cause they're already
So
confirmed.
that's negative, the opposite of the sine of.
I gotta bring the question. The timing of that, as he was processing, Sean, oh yeah, that's trash.
You just had
That's trash. Hey, you can always ask them McDonald's fries, and I always make things.
That is true. That is
I
true.
always.
Are you door dashing McDonald's right now?
No, we're not.
Are you packing up? We're not done.
You have 3
We have
minutes left.
3 minutes.
Sorry.
Yeah, you don't even know if you got it right yet.
Where'd my...
Michael's.
I'm not gonna share my answer until this
Having
video.
Well,
confidence.
and we can
Rohan,
start
are you packing up?
5.4.
I'm confident.
Yeah, we can start. Yeah,
I'm confident.
2 minutes.
Did we get negative root 3 over
I did.
3?
We did.
No, Rohan, we still have time to start the next lesson.
No. Wait, did I?
What?
Now, you could have thought about the general solution set and then just figured out which values. I'm not on DoorDash right now. are we?
Nope.
Figure out which solutions would be between 0 and pi over 2. I just started listing solutions. I thought about the solutions from 0 to 2 pi. And I was like, well, that 2 is horizontally compressing the graphs and horizontally compressing the domain. So only pi over 6 would actually be a solution on that interval. Plugging pi over 6 in, you end up with negative 2 times sine of pi over 3, which ends up being negative root 3. And if you rationalize the denominator, negative root 3 over 3. You pop it back in. You guys, we can totally start 5.4. We're going to do it. We're going to do it. We got to do it.
30 seconds left.
2 minutes.
We have less than.
We can do it. We're just going to start it.
5.4?
Stefan, you're not on DoorDash now, right? Come on.
Low power mode.
Stefan.
Okay, using what we just talked about. So this formula that we just talked about for the derivative of an inverse function. Let's think about two functions that we know are inverses of each other. Natural log and e to the x.
What?
They're inverses, right? That's log base e and e to the x. Okay, so if we were trying to find g prime, that's not what I want. G prime of x using this formula, right? That would be 1 over f prime of g of x. Well, g of x is e to the x. Nah! Cliffhanger!
Is that just to spite us for packing up or
No, I really wanted to get through that. Okay, cliffhanger. You're all on the edge of your seats, I know.
I'm not going to